Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one type of question lost more marks than almost any other on last year's papers. Make x the subject with fractions and a squared term. Students rushed, cancelled the wrong thing, then realised they'd lost method marks halfway through. Sound familiar?
Oh, absolutely. I remember panicking when x was under a fraction and squared. My brain just freezes and I forget to show the steps.
Exactly. And here's the important bit. The algebra itself is rarely the hard part. The hard part is keeping the equation equivalent at every step and writing down enough to snag method marks, even if you slip later. Today, we fix that with a simple 5-step routine and a 10-second check. Let's start with the concept.
The concept. Setup. Imagine the exam gives you this formula. Y equals 2x plus 3 over x squared plus 5. The instruction. Make x the subject. Don't panic. Step 1. Treat it like a normal equation. Your goal is to isolate x, but you must do algebra that keeps both sides equal. We'll work through it slowly and show why each algebraic move is valid.
Quick check. Is it okay to multiply both sides by x squared straight away? I always worry about 0.
Great question. Always consider the domain. If you multiply both sides by x squared, you must note x not equal to 0. In exam scripts, it's enough to state x not equal to 0 when you clear denominators. That keeps your work logically sound and prevents losing marks for an invalid manipulation. Now, follow the algebra with me.
Step 1. Isolate the fraction term. Starting with y equals 2x plus 3 over x squared plus 5, subtract 5 from both sides to get y minus 5 equals 2x plus 3 over x squared. That line is M1, method for starting the rearrangement. Why does this work? Because subtraction undoes addition. We keep equality by doing the same operation to both sides.
So that's the first M mark. You wrote the equation in a cleaner form. Nice.
Step 2. Clear the denominator. Multiply both sides by x squared to remove the fraction. X squared into y minus 5 equals 2x plus 3. Important to say or write x not equal 0 somewhere. You now have a quadratic in x because x appears squared and linearly. This multiplication is another method step, M1 or M2 depending on the mark scheme, but it's always crucial to show it.
Step 3. Expand and collect terms. Expand the left. X squared y squared. No, careful. X squared into y minus 5 means y times x squared minus 5x squared. So we get x squared y minus 5x squared equals 2x plus 3. Now gather all terms on one side to make a standard quadratic in x. Move 2x and 3 over. X squared y minus 5x squared minus 2x minus 3 equals 0. Each algebraic move keeps equivalence. If you do this slowly and write each line, examiners can award method marks even if arithmetic slips later.
That step always confuses me when there's a y. Do we treat y like a number, like a coefficient?
Yes, treat y as a constant with respect to x, so the quadratic is in x with coefficients that involve y. That means you can use the quadratic formula next. Step 4. Identify a, b and c in ax squared plus bx plus c equals 0. Here, a equals y minus 5, b equals minus 2, c equals minus 3. Write them down. That clarity often wins an M mark because the examiner sees you've set up the correct formula.
Step 5. Apply the quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac over 2a. Substitute carefully.
X equals 2 plus or minus square root of minus 2 squared minus 4 times y minus 5 times minus 3 over 2 times y minus 5. Work out inside the square root. 4 plus 12 times y minus 5 equals 4 plus 12y minus 60 equals 12y minus 56. So x equals 2 plus or minus square root of 12y minus 56 over 2 times y minus 5. You may be able to simplify the square root factor, but only if it helps. The final substitution and simplification earns the A mark, the correct subject expression.
That's a lot of steps, but seeing A and B like that helps, and I can imagine losing a mark if I forget the 2 in the denominator.
Exactly. Now let's map that to the mark scheme so you know where the marks come from.
Exam technique. Examiners look for key lines. For this question, you typically see M1 for isolating the fractional term, y minus 5 equals, M1 for clearing the denominator by multiplying by x squared, M1 for rearranging to standard quadratic form, M1 for correctly identifying A, B and C, or for applying the quadratic formula correctly, and A1 for the final correct expression for x. Even if your final simplification is messy, those middle method lines can give you 3 or 4 marks.
So if I get the setup right and show the quadratic formula, but make an arithmetic slip in the discriminant, I still get method marks for the setup.
Yes, that's why you should write each algebraic step. If you show a correct substitution into the quadratic formula, that's a strong M mark, even if the square root evaluation is off. Also, always state domain conditions like x not equal to 0 or a not equal to 0 if a is in a denominator. It shows mathematical awareness and prevents careless losses.
Quick win. The 5-step routine you can use every time. 1. Read and note domain restrictions, e.g. x not equal to 0. 2. Isolate the messy fraction or term. 3. Clear denominators. Multiply both sides. 4. Expand and collect like terms to form a standard polynomial. 5. Divide or apply formula and simplify. Write each step on a new line and label important substitutions.
Can you give a 10-second check that I can do under exam pressure?
10-second substitution check. Pick the simpler root or simplified expression and substitute it back into the original equation's left-hand side, numerically if the question gives a numeric y, or symbolically check that your expression satisfies the earlier rearranged line. In words, substitute and see if both sides match. Takes about 10 seconds and catches around 90% of sign or factor errors. Don't skip the check. That's the difference between an answer and full marks. Don't skip the check.
Worked example. Let's apply the routine to a short exam-style question. Question. Make x the subject of y equals 3x minus 2 over 2x squared plus 4. First, subtract 4. Y minus 4 equals 3x minus 2 over 2x squared. State x not equal to 0. Multiply both sides by 2x squared. 2x squared times y minus 4 equals 3x minus 2. Expand. 2yx squared minus 8x squared equals 3x minus 2. Bring all terms to one side. 2yx squared minus 8x squared minus 3x plus 2 equals 0. Identify a equals 2y minus 8, b equals minus 3, c equals 2. Substitute into the quadratic formula and simplify. If you write each line clearly, the examiner can follow your method and award those M marks, even if the discriminant arithmetic is messy. And if a equals 0, say 2y minus 8 equals 0, then it's not quadratic anymore, right?
Exactly. Always check the special case a equals 0. If 2y minus 8 equals 0, then the equation reduces to linear in x, and you should solve it as a linear equation. Writing that case briefly on the script is great exam practice and can recover marks if the main root becomes invalid. Let that sink in.
Common errors in mini-practice, rapid fire. Error 1. Forgetting to state x not equal to 0 after multiplying by x squared. Practice, when you clear a denominator, write the domain restriction immediately. Error 2. Dropping a factor when expanding, especially when coefficients include y. Practice, underline your A, B, C before substitution. Error 3, missing the 2a in the quadratic formula denominator. Practice, always write the formula on your script before substituting.
3 tiny habits to practice. Any quick prompts for practice questions?
Yes, try these for 5 minutes each. 1. Make x the subject when a appears in the denominator and numerator. 2. Rearrange when x is both linear and squared with a parameter y. 3. Practice the special case where the quadratic coefficient becomes 0. Time yourself and always do the 10-second substitution check afterwards. These short drills build the routine into your exam muscle memory.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.